So, what are rational numbers? Rational numbers include all the numbers we've learned about, so the integers, meaning the whole numbers, and their opposites. Here, I'm going to give you a different one. The pencils and that box that you chose aren't the best ones. So the integers include all the whole numbers and their opposites. So 0, 1, 2, 3, 4, 5, their opposites, -1, -2, -3, etc., etc. Rational numbers, we are now going to include positive and negative fractions and decimals, okay? The definition of a rational number is that it's any number that can be written as a over b, written as a fraction, where where b, the denominator, isn't 0, because we can't have a fraction that has a denominator of 0. We can have a fraction with a numerator of 0. That would mean it equals 0, but we can't have the bottom number equal 0. So that means a number like 3, that can be written as 3 over 1. So that means it's a rational number. Same with 0.5. Even though that's a decimal, what could that be written as in fraction form? 0.5, Emma? 1/2. So because it can be written as a fraction, it is also a rational number. So really today, your brain just needs to be thinking, now we're introducing negative fractions and decimals. So we're going to start by graphing something and its opposite. So this is where we have a number line, and we are going to graph, put a dot or a point on this specific rational number as well as on its opposite. So whenever I'm doing opposites, I always want to put 0 in the middle because I need to be graphing evenly on both sides. My integer and its opposite are going to be equally spaced from the 0, but on opposite sides. And if I need to graph 3/4, if I put 1 over here, how many tally marks do I need to put in between if I need to be able to plot 3/4? Ratisha? The 1 should be my fourth one, exactly. So this is 1/4, 2/4, 3/4, and 4/4, which is equal to 1, right? 1/4, 2/4, or 1/2, 3/4, and 1. And so my 3/4 would go there because I split my 1 in 2/4 and I count to the third one. What is the opposite of 3/4? What's the opposite of 3/4? Reese? Negative 3/4. Not 4/3. I think sometimes we're like, oh, flip it around. Does anybody remember what it's called when you flip a fraction over? That has a name. Swara? Reciprocal. So we want the opposite, not the reciprocal. And the opposite is just changing the sign. So now I'm going to do the same thing on the other side of 0. Again, here's my -1, and I'm going to split that so that it's in fourths. So -1/4, -2/4, or -1/2, -3/4 right there. Questions about example 1A? Okay. Make sure we're taking notes during this time so you have examples to look at later. Next one, we have a decimal number, but I'm still going to do the same thing where I'm graphing that and its opposite, which means I want 0 in the middle, so I have room for this number as well as its opposite, which will be on the other side. -1.6, what does that number fall in between? Which two numbers could we say that falls in between? Dash?
1 and 2.
-1 and -2. But yeah, so I'm going to start by putting -1 and -2 because I know it's going to be between those. And then does anybody have a suggestion about what we could kind of break this up into? What we could make each little tally mark worth? How we could break this up to get to -1.6? Lizandro? Fifths, or in decimal speak, that would be 0.2 or 2/10. So basically splitting it up into 5 little sections because each one will be worth 2/10 or 0.2. So -0.2, -0.4, -0.86, -0.8, and then we get to -1. So splitting it into fifths or 0.2, 2/10. And then I'm going to do the same in between my -1 and my -2. So -1.2, -1.4, -1.6, -1.8, -2. And then I'm going to go ahead and put this at where -1.6 is. So remember, here's -1. Each is going by 0.2. So -1.2, -1.4, -1.6 would fall there. And now I need to also graph its opposite. Who can tell me what the opposite of negative 1.6 is? Kaden? 1.6. So I'm just going to now mirror this on the other side. So again, I'm going to put my 1 and my 2. And we decided we're splitting them into fifths, or again into 0.2, 0.2. So here I'm at 0, 0.2, 0.4, 0.6, 0.8, 1, 1.2, 1.4, 1.6, 1.8, 2. And now I need to graph where 1.6 would be, so that's going to be 3 tally marks past the 1, because 1.2, 1.4, 1.6. Again, make sure that your points or dots are on the number line, not above the number line. Questions about this one? Letitia? If it's a question that says to graph the integer, yes, because the only way to graph an integer is to graph it on a number line. So on your test, you have to be able to say, okay, I have to graph 3/4 and be able to put some labels on there so that you can accurately plot 3/4. You have to be able to count up by a specific amount, right? By a consistent pattern, whatever you choose that to be. All right, we're now going to get into comparing. So comparing some rational numbers, deciding which one is greater or lesser. And we definitely could do this on a number line, and we will, but we're also going to talk about how we can compare these without the number line. So starting with my number line, if I'm graphing only negative numbers, where might I want the 0 to go to give me the most space? Emma? That way I have just the room to the left of it. Now I'm going to start by graphing negative 1/2. So I'm going to put negative 1 here, and I know negative 1/2 is in between those, so it goes just there. Where would negative 3/4 go in relationship to what I've already graphed? Where would it go in between? Would it go in between the 0 and the negative 1/2, or in between the negative 1/2 and the negative 1? Natalie? Yeah, it would go in between these. That's where negative 3/4 would be. So now looking at this photo, negative 1/2, is that greater or less than negative 3/4? Juliana? Because it is further to the right. So negative 1/2 is greater than negative 3/4. And then just as a reminder, because this is the thing some people are going to forget on their assignment, when you're comparing fractions, I know that this one you might be able to do in your head. I totally get it. But truly, to compare fractions, you have to have the same denominator, right? I can't just say like, oh, 1/2 and 3/4, that has different numerators and different denominators. I want to have the same denominator to be able to accurately compare them. So on your paper, you're going to notice there's a couple that say like compare these two fractions. And the reason I gave you a box for that is because I want you to actually show me making them have the same denominator. So in this case, what would be probably our best common denominator between 2 and 4? What would we want to choose? Aubrey? So I can just change this one into a 4 by multiplying it by 2. And remember, whatever you do to the bottom, you do to the top. That turns this into negative 2/4. And then it's a little clearer to see that negative 2/4 is greater than negative 3/4 because it would be closer to 0. So that's what I'm looking for when I ask you to compare two things, two fractions, and there's a box for your work. I want to see them have a common denominator. Questions about that one? Okay, we're going to do this one. Compare negative 4 5/5 and negative 4 1/6. So again, I'm going to go ahead and draw my number line. And this time I'm not even going to put a 0 on here. Where would these numbers fall in between? Which two integers would these fall in between? Neil? Negative 4 and negative 5. So I'm going to put negative 4 here and negative 5 over here because I know these both fall somewhere in between negative 4 and negative 5. And what should I split this into, this space of 1? What should I split it into? Like what fraction or decimal, or what should I split it into? Based on what they say. What do I want to split that into? What do you think? Grayson? 6, because I need to graph 5/6 and 1/6. So here's negative 4 And then I'm going to do like a halfway point just to keep my things evenly spaced. So this would be half or 3/6. So here's 1/6, 2/6, 3/6, or 1/2, 4/6, 5/6, and then 6/6 is where you reach the next whole number. So we've split it into sixths. I'm now going to graph -4 and 5/6, which would be almost to the -5, and then -4 and 1/6, which is almost to the -4. Now that we see that, -4 and 5/6, is that number greater or less than -4 and 1/6? Is that one greater or less? -4 and 5/6, is that one greater or less than -4 and 1/6? Dash? Less, because it is further to the left. This one, you wouldn't have to like show your work for necessarily because the denominators are already the same, and a lot of you maybe already recognize, well, if the whole number component is the same, this fraction is closer to 0 than this one, therefore that's the greater negative number. The other one must be less. Questions about that one? Okay. And then our last two, we're now going to compare some negative decimals. Again, the reason we're doing the number lines on all of these is because you do have to be able to create a number line that is like counting by a consistent pattern, like going up by halves or fourths or sixths or something like that. You have to be able to know where those things fall. So here I have -2.3 and -1.5. What range could I maybe use on my number line here? I, again, don't really need to put a 0 on this one. Maybe what could I start at and what could I end at that would include both of these? Samson?
2.
I could start at -1, but if I put -2 here, -2.3, would I have room for that, or would that be past that? Dash? Because the -2.3, that is past, that is further to the left than -2, right? It's between -2 and -3, not -1 and -2. So I need my range to go from -1 to -3. That means -2 is in the middle. Okay. And then what could I maybe split each of the ones into, like in between -1 and -2? How many little tally marks, or what would I maybe want to split this into to be able to graph those two things? Ratisha? If I do fifths, 0.3 is not going to be able to necessarily fall on one of those tally marks because fifths would be 0.2s, and if I count by 0.2s, 0.2, 0.4, 0.6, 0.8, I don't get to 0.3. So what could I maybe go by instead of fifths? Tanisha? Sorry, what was that? So it's already going by ones.
What? She means like 10.
0.1s or tenths. So I'm going to split it into, the midway point would be my 0.5, okay? So that helps me kind of guide myself a little bit. So -1.1, -1.2, -1.3, -1.4, -1.5 in the middle, which I need to graph, so I'm just going to put a dot. -1.6, -1.7, -1.8, -1.9, -2. And now I'm going to do that same spacing in between my -2 and 3. Again, I personally like to do the halfway point at the beginning. It just helps me space it more evenly. So this would be -2.5 right there. So I'm going to go -2.1, -2.2, -2.3, -2.4, -2.5. And I'm going to plot my -2.3 because I already have enough room for that. That was 3 little tallies to the left of -2. -2.6, -2.7, -2.8, -2.9, -3. And now using this, -2.3, is that greater or less than -1.5? Is that greater or less? Juliana? Because it's further to the left. Questions about 3A? Okay, we have our last one. This one is one that people oftentimes will make a mistake on. It says compare -3.08 and -3.8. These are not the same number. I know they both have an 8 after the decimal place, but one of them is in the tenths and one is in the hundredths. So that means they are different numbers. If I were to show these on a number line, I'm going to kind of do this one for you. I might choose to put -3 right there, -4 right here, because they're both between -3 and -4. And then if I started by graphing my negative 3.8, I might go, this one, I might go by tenths or 0.1s like Tanisha had suggested last time. So here would be my midway point. That would be like negative 3.5. So negative 3.1, negative 3.2, negative 3.3, negative 3.4, negative 3.5, negative 3.6, negative 3.7, negative 3.8. That's what I wanted. Negative 3.9. So this is where negative 3.8 falls. Where does negative 3.08 fall? I don't have an exact tally mark for it, but where would it fall in between? Shelby? Yeah, it would fall in between here, and then can somebody else tell us, do you think it'd be closer to the negative 3 or closer to the negative 3.1? Where would it be a little closer to? Mia? Yeah, because it's if you think about rounding, that's almost to negative 3.1. So I would put it like about there. Using that information is negative 3.8, greater or less than negative 3.08. Juliana? Close. And I'm going to show you one other quick way to have compared these without graphing them. If I put a 0 on the end of my negative 3.8, it's like you're comparing 3.80 and 3.08, right? 80 hundredths versus 8 hundredths. We can tell that those 8 hundredths would be closer to 0, meaning in the negative world, greater. Questions about that last one?